I'm Ennemcien. Let us see a problem from gravity. A and B are two identical satellites revolving in the same circular orbit around the Earth in opposite directions. They make completely inelastic collision, taking the Earth satellites system together. Find the ratio of total energy before and after collision. This is the question. Now, before doing the problem, let us see a background. Now, what is the total energy of Earth and planet satellite system? The satellite is revolving in a circular orbit, then what is the total energy of the combined system, Earth and satellite? Capital M, mass of Earth, small m, mass of the satellite, radius of the orbit is small r, that is the distance between the satellite and Earth is small r. Then potential energy, total potential energy of Earth satellite system is minus g m into m divided by r. We have seen it earlier. Minus g m by r. See this. Earth satellite, orbital velocity of the satellite is along the tangent to the orbit. Distance between the two is smaller. Then potential energy equals minus g mm by r. Now these are all constants. G, m, m, r. All these are constants, so let us put it as k. So potential energy is minus k. Now we have to find the kinetic energy. Kinetic energy is half mv square. How to find out this kinetic energy? First you find out mv square. For this, in the case of satellite, the centripetal force is provided by the force of gravitation between Earth and the satellite. So we can equate centripetal force mv square by r equals gravitational force g m into m by r square. One r would go. Then we get mv square equals gmm by r. So multiply with half. Then you get half mv square equals half into gmm by r. Gmm by r is k. So kinetic energy equals k by 2, half into k. Now from this it is clear that kinetic energy equals half of the modulus of the potential energy. That modulus means without sign, only its value, magnitude. Potential energy is minus gmm by r, so modulus is gmm by r. So kinetic energy equals half of the modulus of potential energy. Now then the total energy E equals kinetic energy plus potential energy. That means k by 2 minus k, or minus half gmm by r, plus half gmm by r plus minus gmm by r. That means minus gmm by r. So half minus 1, that is minus half. So total energy is minus half gmm by r, or minus k by 2. So total energy of the Earth satellite system is minus k by 2, where k equals Gmm by r. Now we can see this problem. Here the problem is two satellites A and B are revolving around this Earth in a fixed orbit. The two are moving in opposite senses. One is moving clockwise, the other is anti-clockwise with the same velocity. The satellites are identical, so mass is the same. Now here, what is the total energy? Total energy of the satellite Earth satellite system equals potential energy W. Let it be W1, total initial energy before collision. W1 equals potential energy plus kinetic energy into 2. Because there are two satellites, so total energy, you should multiply potential energy plus kinetic energy into 2. Potential energy plus kinetic energy is nothing but minus k by 2. We have seen it. So minus k by 2 into 2, or that is minus k. Now the collision is said to be perfectly inelastic. That means since the mass is the same for both and velocity has the same magnitude and coming in opposite directions, after collisions, the collision being perfectly inelastic, the two will stick together and come to a stop. In the tangential direction, there won't be any velocity after collision. After that, we forget about it. What happens after some time, we are not concerned. Just after collision, the two come to halt, the two come to rest momentarily. Then the total energy. So here the kinetic energy becomes 0. Still there is potential energy. And that potential energy is, after collision, W2 equals potential energy plus kinetic energy is 0 into 2. Potential energy is minus k into 2. So the ratio of the initial energy to final energy, W1 by W2, is W1 is minus k, W2 is minus 2k. So W1 by W2 is 1 by 2. That is the answer. Thank you.